Hi guys, so let us see some important questions which has been asked in previous year GATE for communication subsystems in ECE branch as well as instrumentation branch. So this amplitude modulation is quite important topic and minimum 1 to 2 questions like comes every day. So if you want you can refer like theory videos for all the derivations and concepts that I will be using here. So let us start with first question. The question is an amplitude modulated signal with total power is 50 kilowatt, modulation index is 0.8. Find the power in the intelligence part. See, so the thing that he is asking is intelligence part is nothing but the power in sideband. Okay, so you know already AM power total is how much? PC into 1 plus mu square by 2, right? Where it is like a summation of PC like carrier power plus PC into mu square by 2. So this part is nothing but your intelligence part, which is PSB. Alright, so this PSB can be found out very easily. How? The total power is given and modulation index is given. So let me directly take you to the solution. So you have total power 50 kilowatt, mu is 0.8. By putting these two values in this particular formula, Pt is equal to Pc into 1 plus mu square by 2, you are going to get how much? Pc, because carrier power was not given, total power was given. So put the Pc is equal to Pt by this, so Pt is 50 kilowatt divided by 1 plus 0.8 ka square, that is 0.64 by 2. So if you solve this, you are going to get 37.88 kilowatt. Alright, now to find out what is your power in your intelligence part, either you can do two things. You can do P sideband is equal to total power minus this PC, that carrier power, so which will give you 12.12 kilowatt. Or another way you can do one more thing. Your sideband power can be written as PC into mu square by 2. So PC was already found out, 37.88 multiplied by PC mu square, that is 0.8 square is 0.64 divided by 2. So this is going to be 37.88 multiplied by 0.33. Let me do that. Multiplied by 32. So this is going to give you 12.1216 kilowatt. Understood? So this is the way you can find out very easily. Alright, let's move to next question. So we'll solve minimum like 10 question each video, so that you have a complete understanding of all the kinds of problems that will be asked. Yeah, in this question, in an AM signal with 100% modulation, okay, and carrier power is given 20 kilowatt, amplifier efficiency is eta is equal to 80%, the input power of the amplifier is, see, I have written the questions in notation form. So 100% modulation means mu is equal to 100%, that is nothing but 1, okay, and efficiency eta is 80%, that is 80% means 80 by 100, that is 0.8. So this is the meaning, okay, and PC is also given, which is 20 kilowatt. So we have to find out what is your input power, okay. So let us do that. If you want you can directly find out by yourself. uh, Take a minute time and find it out, or otherwise we will proceed this way. What will happen? You have total power is equal to PC into 1 plus mu square by 2. So you guys have every values. PC is 20 multiplied by 1 plus mu square is 1 by 2. So that is going to give you 3 by 2 into 20, that is 30 kilowatt. So the total power in AM signal is 30 kilowatt. What is your sideband power? Why? Because we want to like relate this thing with the efficiency. So the efficiency is related to, what is that, P sideband by total power or P input, okay. So the sideband power, that is that is like calculated that can be calculated as PSB is equal to PC into mu square by 2. So PC was already found out, already there. 20 kilowatt multiplied by mu square is 1 by 2, that is 10 kilowatt. Alright. So what would be your eta? So moving on, eta can be written as 10 divided by P input is equal to eta, that is 0.8. So from here I can find out P input power is 10 by 0.8, that is 12.5 kilowatt. Understood? There are one more meanings, like you can say I have taught you eta is equal to sideband power by total power. Okay, so with this it is not related right now because the input power is being asked. So input power is always predominant, compared to the total power. So input any efficiency is actually related to output power by input power. Okay. So that's all, 12.5 kilowatt. If you want, you can take this proper screenshot or something. Okay. Taking to the third question. In an AM transmitter, unmodulated carrier current, see, unmodulated carrier current, it is not modulated. Okay, so IC is given as 18 ampere. Modulated carrier current is 20 ampere. So modulation index is being asked. So I had told you the total power was PC into 1 plus mu square by 2, and P was related as I square into R. So from here I had related. So you don't have to remember the formulas again. You can write down directly IT square is equal to IC square into 1 plus mu square by 2. And you can see the total current IT is given 20 and IC is given 18. By putting these two values you can find out the mu values. So let me give you the formula directly here. 20 square is equal to 18 square into 1 plus mu square by 2. Alright. So mu square by 2 can be written as how much? 20 square is 400, 18 square is 324 minus 1. Okay. So it's up to you, like how quickly you you calculate these values. Okay. So 400 by 324 is actually 1.68. 400 by 324 is 1.23 minus 1, so that is going to come up as 0.23. Okay, and 0.23 into 2 is 0.46. So mu will be a square root of 46, that will be 0.68, that is 68%. Okay. So see, very simple questions were being asked, like in amplitude modulator, like what is the total power, what is the sideband power, or what is the modulation index, or something like that. We'll slowly proceed to much difficult questions that has been asked. Let's take another question. An AM signal is simultaneously modulated by two sine waves of, see, two sine wave it is asking. One is mu1 is equal to 0.4, mu2 is equal to 0.3. We have to find out the resultant modulation index. So I had told you the resultant modulation index mu2 square is mu1 square plus mu2 square. So from here 0.4 is 0.4 square is 16 and 0.3 square is 0.09. So that can be 0.25. So mu t will be a square root of this, that will be 0.5. So the overall modulation index, the resultant modulation index of due to these two sine waves in amplitude modulator is going to be 0.5. So you can take a note of this directly from here, that the overall modulation index is 0.5. Let's take another question. In an AM signal, you have been given like carrier power is 50 kilowatt, mu1 is 30%, mu2 is 40%. Okay, the total power he is asking in the amplitude modulator. So what will you do? PT is nothing but PC into 1 plus mu square by 2. So mu square is nothing but mu t square. Okay, the total modulation index. So you have mu1 is equal to 0.3, mu2 is equal to 0.4, mu2 will be what? Square root of mu1 square plus mu2 square. So that is going to be 0.09 plus 0.16. Okay, why 0.09? 3.3 square is 0.09. So that is going to come up as 0.25 square, that is 0.5. We just now calculated in the previous question. So by putting these values, we can have PC is 10 kilowatt into 1 plus 0.5 chi square by 2. So that is going to come up as 10 multiplied by 1 plus 0.25 by 2, that is 0.125. Okay, so that is going to come up as 1.125 multiplied by 10, that is 11.25 kilowatt. So with these two simultaneous modulation indexes like 0.3 and 0.4, the total power in amplitude modulation is 11.25 kilowatt. So you can take a note of this. Alright guys, so we will solve some more question in our next videos. Thank you so much.